for giving me the opportunity to conduct this workshop. Git has always been one of those concepts that's been very difficult for me to learn. It took me, I want to say, like at least 4 years of industry experience to understand it and finally say, yeah, I get it now, pun intended. So I totally get it if some of you are on the same boat and struggling. This is supposed to be an interactive, collaborative session where we go through exercises together. Some housekeeping items, if you have questions, please put that on the chat. Or raise your hand, I'll call your name out. Or actually, you know what, I think we have a manageable amount of participants. If you just want to mute yourself and say, hey, I have a question, that is totally fine too. Another housekeeping item is I did send out a link for a PDF on the chat. So feel free to download that. What that has is a bunch of workshop exercises that we can do today together. Those exercises are totally optional. So I highly recommend doing them. But if you just want to sit back and watch me do it, my only recommendation with that is try to visualize what each command does, how the data flows, and I think learning Git will be a lot easier that way. Try to visualize as much as you can. I know it's hard, but bear with me. We're in this together. All right, so let's talk structure of the workshop. We're gonna cover what is Git, why do I need to learn Git, why is Git every software developer's best friend at some point. We'll also study, I guess, or like learn the history of version controlled systems and how Git evolved. Then we'll touch upon some basic Git commands that developers use, on an everyday basis when they work on software engineering projects. Then we'll study branching. I say study, feels like a study session to me. Then we'll cover branching in Git, which is actually one of the most important features that kind of sets Git apart from other version controlled systems. And then we'll talk a little bit about just GitHub, open source projects. If you're starting as a developer, how can you learn from GitHub? And how can you contribute to the GitHub projects? And then I'll leave the session open for Q&A, but feel free to just unmute yourself, interrupt me if you want to ask questions. That is totally fine. As I said, I think we have a manageable number of participants where, we can make this a collaborative and interactive session. All right, so let us entertain a scenario. I am currently the maid of honor for my best friend's wedding, so please humor me. And just imagine you are all also the maid of honor or the main event planner for your best friend's wedding, okay? And planning a wedding actually is, it's crazy, right? There's a lot of tasks. You need to organize a guest list, you need to organize a floral list, etc. But good news is you have a team of bridesmaids or friends or groomsmen to help you out with all of these tasks. I'm going to add some constraints here as you're imagining the scenario. Let's say that you're in an island where there is no internet connection, okay? And all you have is probably physical copies of binders that you work with to kind of do this documentation task of, let's say, organizing the guest list, okay? How would you collaborate? Think about it for a second. I have some ideas here on the slide. One is to maintain a central binder. So since you are the main event planner, maybe you have a central binder in your location. And when everybody wants to add a guest to that binder or guest list, what they would do is they'd either call you, come to your place, they'd check out that binder, add their entries, check it back in. So really the responsibility of making sure duplicate or the same guest is not added twice is on the person who is checking out the binder and then adding that entry and checking it back in. What are some potential disadvantages with this scenario? One is only one person can work on this task at a given point of time, right? And it can be cumbersome to wait on someone all the time before you have to work on that task. So let's entertain our second scenario, which is maintaining local binders. Everybody has their own binder they're working on. The problem with this is duplicate guests can be added, right? And that's okay, because then you can have a merge party of sorts where you'll all meet and go through the cumbersome task of sorting guests and making sure you're creating that main binder guest list, I guess. So that's scenario 2. Seems cumbersome as well. Now here's where I really want you guys to be creative, go in a fantasy world. Imagine the concept of a magic binder. Every member in your team has a magic binder that has 2 buttons, let's say. One is a sync button and one is a push button, okay? So what you're doing here essentially is you're all independently able to work on your task, which is adding guests to the list, right? Once you click the push button after adding guests, what this does is make sure every other friend of yours or every member in your team gets that list of guests or gets an updated list of guests. So you're all in sync with each other. And you click the sync button to make sure that you get everybody's entries as well. So this way, this is one way of saying you all have an up-to-date version of the binder every time. I know, crazy scenario. In the real world, we'd all be using Google Drive, but for now, let's just assume magic binders are what we're going with. This is actually synonymous with Git, and you'll understand why in the next couple of slides. So what is Git and why Git? And bear with me, it'll all come together in the end. But for now, let's say Git is free. It's an open source distributed version control system. What do you mean by open source? It means you grant rights to use, distribute, and learn. It's free to use, and it's a version control system. Because it stores files over a period of time, it tracks that. So you have different versions of the file across a certain period of time. And you also know who's doing what with each file. And I think a good way to think about this is the example of an animator, right? Someone who's drawing cartoons, they have different versions of the cartoons progressing. And all of those like versions make a moving image, right? Or a moving cartoon. So think about it that way. That's why versioning is, for the animator at least, that's why versioning is important. With that, let's go into a brief history lesson. Actually, I'm gonna pause here. Do we have any questions so far? I'm gonna take silence as no. No questions? Okay. So let's go into a little bit of a history lesson with version control system. First, let's start with what is version control? System that records changes to a file or a set of files over time, right? So you're having different versions of a file over time. That is version control. Now, you can revert changes. If you have different versions, you can view changes over time and meta information such as, at what time, who edited what file, etc. I think my computer is stuck. Can you all see the next slide? Yes, okay. Local version control systems. Now, assume the guestbook example again. So let's say that you now have access to a computer. So you actually have a local file in your computer where you're maintaining the guest list. A simple way to version control this would be, let's say you add 3 guests to your notepad file. You can save that as version 1. The next day you want to add 4 other guests. You can add 4 to the same file, but save it as version 2. So you still have version 1 with 3 guests, and you have version 2 with your 7 guests, right? That is a simple way to version control it. If you're smart, you'll probably put a timestamp with it so you know at what time you created your version. Developers then created something called a revision control system. What this does is it stores changes to a file in a local database, as you can see right here. So you can recreate a file at a certain version by adding up all the changes from the database. Sense? Both these tasks are local. They're local version control systems because you cannot collaborate with anybody in these tasks. Let's go to the next slide where we have centralized version control systems. So in this, as you can see in the diagram, we have a central server that has a version database that stores all our files. And then we have the collaborator computer A and the collaborator computer B. What they do is they'll check in and check out a file from the centralized or central server. This is actually synonymous with the very first scenario in our guest list binder scenario, right? Think about it, because only one person had a centralized binder and all the other team members had to check in that binder when they wanted to perform the task, or check out that binder when they wanted to perform the task. And then once they were done with the task, they checked in that binder. So that's kind of synonymous with the centralized version control system. What are some of the drawbacks to this? Very similar to what we saw back then, right? Only one person can work on a file at a given time. The advantages are everybody knows what's going on with that file, right? There's more oversight, more control, which is neat. But then the disadvantage is you have to wait on someone else. And another huge disadvantage is, should your server fail, and if you do not have proper backups or a disaster recovery plan, you're losing all your data, which isn't fun. So that is centralized version control systems for you. Let's then visit distributed version control systems. So over here, what you can see is we have a server computer. We also have computer A and computer B. But notice the difference between the previous diagram and this diagram here. Everybody has all the data, right? So you have all the files here. Computer A also has all the files. Computer B also has all the files. So if you can recall scenario 3 with our magic binders, that's kind of what we had. We all had binders and we all had the sync button, and every single time it clicked on the sync button, we had all the data that everybody else had, right? So we call that a clone here. So everybody has a clone of what's in the server computer with the full data, all versions, all history. Wonderful. So that is Git for you. Git is a distributed version control system. You do not need to wait on your team members to check in files. Everybody can perform the same task at the same time locally because they have a copy of the data in the files, the full clone. Another big advantage is that should the server computer fail, let's just say it loses all its data, one of these collaborators can back that up with their copy of the data, provided they did good housekeeping, synced very often. You know, this shouldn't be a problem. So then let's talk a little bit about how files are stored. So in other version control systems, files are stored as changes. So as you can see here, in version 1, we have file A, B, C. In version 2, all the changes that are made to file A are stored. The changes that are made to file C are stored in version 2, etc. So think of this as storing changes. That's what all other version control systems do. Git is very different in that way because Git does not store just the changes. What Git stores is a snapshot of the file. It's kind of like a picture of the file as is with its updates, right? So you can see in version 1, we have file A, file B. In version 2, file A has changed to A1, B still remains the same, so on and so forth. So you have the full file saved. So advantages of Git over other systems. I'm going to repeat what I said. You don't have to wait on other people, right? Every operation is local. You don't have to wait. You don't have to be connected to the server to check in or check out files. You have a full copy of all the files. You can edit them, work on them. Don't need to be connected to the network computer unless you want to sync or you want to push your updates, etc. It has integrity. That is because you can it's almost impossible to like delete data or lose data here. Every single change that you make is tracked. So those are the advantages of using Git. All right. Next. Let's get started with learning some Git basic commands. Very fun. So there are lots of different ways to use Git. One is via command line. I like using command line because it supports all the commands, but there's also like GitHub Desktop and other softwares that you can use. Visual Studio comes with Git, so I wish I could show that, but yeah, if you have Visual Studio, you'd be able to see in your bottom right-hand corner, there'll be some controls where you can push and pull and use some of the Git basic commands. Also, going forward, when I use the term repository, please know that repository is just a software project that you're working on or any app that you're trying to build that's on the server and for you locally. There are two ways to get a project or two ways to create a repository. So you can go to GitHub. So also another thing, sorry, when I say server computer going forward, I'll just talk about GitHub. That's essentially the server for all the project repositories. So I'm just going to use the word GitHub for that. So yes, there are two ways to get a project on GitHub. One is to go directly to GitHub and create a repository. Another way to do it is by locally pushing a project from our computer to GitHub, as long as we have that remote server connection set up. For the purposes of this workshop, we will only focus on one of those ways, which is uploading or not uploading a project locally, which is creating the project directly on GitHub. All right, we are actually coming very close to exercise 1, but before that, let's visit the 3 important states. So these, let's assume for a second that you actually have a GitHub project locally, right? Remember, every collaborator to a project has a full clone of that repository, meaning you have all the data, all the files, all the history. So you already have that locally right now in your laptop. There are 3 states. One is modified. So if you make changes to a file, the state changes, right? Now you've modified the file. Once you've modified the file, you can stage the file, meaning you can basically tell Git that this file is ready to be in the next commit, like save the snapshot. Once you commit, you're actually saving the snapshot of that file. Finally, push and pull operations can be performed where you can push all of your changes to GitHub, but we'll revisit that later. For now, remember these 3 states are local. So you have the modified, you have staged, and then you have committed. Any questions so far with these 3 states? I'm gonna check the chat.
Hi.
Hi.
So what part is modified? Is it just like saving the file? I know add and I knew add and commit were local, but I'm not sure about the modified part. So
Oh, it's just a state. Like, so with modified, once you change a file, it can be staged or it can be unstaged, but modified is a state that it's Git is basically tracking that file saying, hey, this person changed this file. So this is a new file now. Once you stage it, that file is ready. Yeah. So it's Git's way of tracking what's going on with all the files. Does that answer that?
yeah,
question?
I think it's a part in Git status, right? Like it shows the file in red. Oh, okay. Thank you.
Exactly. Yeah. That's exactly it. Yeah. Any other questions?
I feel like I missed something in the beginning. So GitHub is basically like a platform for multiple developers to work on the same project.
So let me actually go back to one of the diagrams. Maybe that'll provide some clarity. All right, so this server computer that you see right here, that's basically, just think of it as another place where your repository or project is. That's GitHub for us. Computer is your computer. Computer B is another collaborator's computer. So you all have a project on GitHub. You also have it locally, and you interact with the server computer, meaning you interact with GitHub, you push changes, and you sync changes. Does that make sense? Is that clear?
Yes. Yeah. I think I might have missed a little detail on that before.
Yeah. No worries. I actually forgot to explain it on the slide, and I just like slated that in the next slide, so I totally get it. Any other questions? Good questions. I like this. Why is there an arrow to a green file bubble? Is that green file a single file? Sherry, do you mind telling me which slide was it? I'll just move through different slides. Maybe you can stop me. Was it this? So basically in this, the green file, oh, so you're asking what the file is? It's just a file, and these are the different versions in the database. It's a file that computer A is working on, maybe a file computer B is working on. So do 3 versions collapse to one file? So basically in Git, every version is stored. So no, those 3 versions do not collapse to one file. It's just saying that you have a file, that file has different versions in it. You have version 1, version 2, version 3. Version 3 is the latest version that computer. I don't know if I'm explaining it right, but there are different versions of the same file that everybody has. All versions, everyone has it, including the server computer. Does that make sense? 3 versions of the same file, correct. Yes, that is correct. All right, so with this, let's start exercise 1. I'm gonna give you, let's see, how are we doing on time? I think let's take 10 minutes to work on exercise 1. So basically steps 1 through 14. I know some of you do not have a GitHub account yet or do not have GitHub downloaded. So let me know when you've downloaded that. I'm sorry, my cat's trying to join the session as well. Maybe put him down. So yeah, start with downloading Git, creating a GitHub account, and after 5 minutes, what I'll do is I'll start from step 7, where I will show you how to create a repository and how to clone that repository into your local machine. And also, if you could all just give me a thumbs up or a check mark on, against your profile when you're done with these steps until 7, that would be great. And if you already have GitHub and Git set up, just give me the thumbs up and check mark. Thanks, Ray. Appreciate it.
I just had a comment. People were asking about what is GitHub, and I think it's only fair to indicate that it's a commercial platform where that will host Git repositories, but it's not the only one. There's the other one that comes to mind is GitLab, but there are other ones. Yes. GitHub is the most well known, but there are some ramifications for getting a free account there and parking your project there. And if you don't agree with their policies, you might want to look at one of the other commercial repository hosters.
Absolutely, yeah. No, thank you for that.
Quick question. So on Git, I'm trying to download it for the Mac OS. Am I downloading everything that it shows there? Homebrew, Xcode, binary installer, building from the source, all that?
Oh, no, I don't think so. I think you should. So you're trying to download Git, right? From the Git
I did
SCM.
GitHub.
Okay.
I did GitHub now. I'm trying to download Git.
Which link is it the gitscm.com downloads?
Yes.
Okay,
I'm looking at the download for Mac OS right now.
Let me actually look at it real quick in my phone.
You have different.
Yeah, I would check if you don't have it already on your system. Just go in a terminal and check Git version, and I believe it's included already in your installation.
Oh, okay, let me check that.
Yeah, either that or when you go to the page, there are different options. You don't have to use Homebrew. You can use the binary installer or the source or whatever. It's a list. You don't have to go through all the steps. You have to pick one of them.
Thank you for that.
Okay, thank you.
I actually had Mac OS like 3 years ago, and so I don't remember how to. Sometimes it's challenging to use that.
Hi, I'm sorry, but how do you check if you already have GitHub on your computer? I'm in the terminal right now, and is there something that I would need to type in?
Here, let me actually. You can check it in command line. me actually quickly, yeah, Git version.
So I did type that in. I don't. It's saying command not found.
Then you probably don't have Git.
In that case, which one do I need to download from that page?
What OS do you have? You have Mac OS, you said?
Yes.
Let me actually, since I'm sharing my screen, I'll have to like look it up on my phone. Let me tell you. So if you click on Mac OS, there's a couple, right?
Mm-hmm.
Maybe you can try Homebrew, brew install Git. I think Xcode is fine too.
It
That's
takes
just a
it
package
takes a
that you
little
can
longer
download
if you
and
have
run.
to install Homebrew and then install Git. I think one of the options is for the binary from SourceForge is the one that I just linked in the chat. It's the third option on the website, and that should work.
Xcode takes a long time to download. Okay. Thank you, Ray.
Awesome. Thank you.
I think there's confusion at step 6. This is just to set your global username in your command line. You don't have to do it. I have a note in there saying that when you push and pull, it may prompt you to like log into your GitHub. That's fine. You can take care of it then.
Yeah, hi, just FYI, I'm on a Mac. I typed in Git version on the terminal. I got a response, Xcode select, no developer tools were found at applications/Xcode, requesting install. So it gave me an option to install developer tools, and it's like downloading a bunch of developer tools, whatever they are, and, and hopefully Git is included. So it's like taking 12 minutes for it to download. So whatever it is.
So I recommend, if that's the case, and if you're not able to get the download working, no problem at all. Just try to watch me do the exercises, and then this is being recorded. We also have the PDF instructions. I'll also send you the slides. So definitely recommend trying this after the workshop so you understand it better. I think we can move on to the next step. So I'm going to go ahead and show you how to create. I know I'm not sharing my screen, but I will again in a bit. There we go. So I'm going to show you how to create a new repository. This is going to be step 7 onwards. So you can go into repositories right here, or you can just click on new right here. I'm going to create a repository called Learn Git. Super straightforward. I'm going to create the repository. There is another way to create the repository. You can just push it from your local computer. But right now we're just going to go with this approach. So you see this HTTPS link, right? I'm going to copy that link. Then I'm going to open command line. And I'm just going to navigate to a directory where I want to clone this repository. And then I'm just going to use the simple command called git clone. I'm going to clone that repository. So once that happens, if I open my folder, I should be able to see that repository in here. You see that? And if you actually look at your hidden files, you should see a .git folder. I thought I saw a raised hand. Will I increase the font size? Yes. You mean for my command line? I think you can zoom your screen, or not zoom. I think you can try to like zoom in on your screen, Sherry. That might help. Or is everyone feeling like this is too small? The command line text?
It's clear for me.
Okay. So everything that I'm typing in here should also be in your PDF. And yes, I can back the steps up again. So all I did was quick recap, exercise 1. All we did was we created a GitHub login. We also set up a GitHub account, downloaded Git, and then we went to GitHub, logged in. Once we're on the main page, we can go into repositories. Once you go into repositories, you can create a new repository. Okay. You are the owner of the repository. You can give it a name, any name that you like, so maybe like Codesmith, workshop, something like that. You can add a description, and then you can click on create a repository. Once you create that repository, you have an HTTPS link. So copy that link. That's going to be how you clone the project locally. Once you do that, go into your command line. So go here. If you use Windows laptops, it's easy. Go to command prompt, open that, and go into any folder. Maybe you have a documents folder where you organize all your projects, or maybe I have it in my source and repos folder. So navigate into that and just type in git clone. So that's the command, git clone, and copy paste the URL that you have. What that does is it creates that repository for you locally. So I think I should see mine. Is it me? Yeah, so Codesmith Workshop, I see that. Normally, when you probably clone repositories, it comes with a lot of data. You probably already have code with it, but I created an empty repository on GitHub and I cloned that. That's why I don't see anything here. Once you go into that, you should see a hidden folder called .git. Cool. All right. That concludes our exercise 1. I was going to say that concludes workshop. All right. Give me 1 second. Trying to find my slides. There we go. So let's go on to the next one. We're going to revisit a few other commands that will be useful in our exercise 2. So with git initialize, git init, you're initializing a repository locally. This is only if you were to locally take a project folder that you have in your laptop and push that into GitHub, which we are not doing right now, so you can ignore that. So the next one is git add file name or git add space dot. What you're doing this is you're basically, with this command, what you're saying is you're asking Git to track all of the files, right? So that's where the states come in. So if you're tracking all of the files and if you're changing all of the files, that's when you enter the modified state, then you can stage it, you can commit and push that. So you can add new files and just specify the new file name, git add new file name, and what will happen is that will be stored in your commit. So git commit, what this does is it captures a snapshot of the file as is. So you're basically saying git, hey, this file is important, store this file. I'm going to push this into GitHub sometime soon, possibly or not, but you're basically storing a snapshot of that in your local database. And then you're going to do a git push. Now, when you're doing a git push, you are interacting with GitHub. Or to the point someone mentioned, it doesn't have to be just GitHub. It can be any server computer that is hosting your repository, GitLab or whatever. So in this case, it is GitHub. So when you do git push, that is when you're interacting with GitHub, right? Then there's other useful commands we can run. There's the git status, which shows you if a file is modified or what stage, if it's staged or etc. And if you run git status -s, shows you a shorter version. I'm just saying that this is something that will run in exercise 2, so keep that in mind. We also have git log. Git log, like I said, it's a version control system. It's nice to see the history of what happened with these files. So git log can show you that. Working with remote. So To collaborate, you need to know how to like work with the server, right? Because you're all going to interact with the server at some point, in this case, GitHub, and you're going to do push and pull operations to get the full clone of data, etc. So if you were to run this command git remote -v, what this shows is it shows you the server, or which the link that we just copy pasted, it's going to show you that, because that is where you are pushing and pulling from, right? And then there's the git fetch and git pull. Actually, bonus points to anyone who wants to take a stab at what these two operations are.
I'll take a shot.
Sure.
So I believe git pull is you're connecting to the GitHub server, and you're essentially fetching, or you're getting the version history from GitHub, along with the latest version. Git fetch, I think, only just gets the version history.
Absolutely. So I actually have an analogy for that. And that is, assume that you have, so both of these, by the way, are pull operations. What that means is, remember the magic binders that we discussed with the sync button? What you're doing is you're getting data from the server, correct? But the difference here is that with fetch, you're getting the data, but it's not being applied to your files. With pull, it is being applied to your files. And the analogy that I had for this is, imagine you have your favorite product and the main factory came up with a new line of product that you're interested in. You go into your local store, they don't have that product. The local store fetches the product from the main factory, but just because they fetch the product in the main factory does not mean you have that product. At some point, you still need to go to this local store and buy it. This is a funny example I came up with. I'm not sure if that makes sense, but just know that when you get pull, changes are applied to your files. You can see them. With fetch, that's not the case. Don't worry if this does not make sense. We have exercise to go through that. Great, next slide. Pushing to remote, yes, this is simple. So it's kind of like the push button in the magic binder that we discussed. When we make changes to files and we have commits, we store them in our local database. And at some point when we think we're ready to push all of our changes for everybody else to see, we can push that using the git push command. This is also something we will see in exercise 2, merging and merge conflicts. So what happens here is sometimes how we're going to do this in exercise 2 actually is I'll have you pretend like you're another collaborator in your team. You're going to go onto GitHub directly and you're going to edit the same file that you have been working on locally, right? And probably the same line too. So then this time when you get fetch, or actually this time when you get pull, what's going to happen is it's going to do a fetch and a merge. And what's going to happen is Git's not going to know, because Git's going to get confused. It's going to say, hey, remote's telling me this line should be this, but locally you have something else in this line. Which one should I take? So that is a merge conflict, and we will talk through how to resolve that in exercise 2. I see some raised hands. And I'm going to address chat questions. In the meantime, if you guys want to take a stab at some of the exercise 2 items, I think that starts from step 13. That would be awesome. Questions? At what point do I need Git in it? Yes, so let's assume that you don't have a project on GitHub yet. You have a project locally and you want to put it on GitHub or any server for that matter. At that point, what you're going to do is, you remember the folder I showed you, the hidden folder, the .git? when you do a git initialize, you're kind of like initializing that folder. You're just asking Git to track all of the files in that folder, and you're going to push that to the server. Does that make sense? So it's your way of pushing your project to GitHub or any server. Any other questions?
Yeah, I have a question.
Sure.
About the command git remote with -v. I see that I'm seeing two lines, the origin and the URL for the repository, and in parentheses fetch, and then another one below that is push. I'm trying to understand why there would be two for fetch and push separately.
Oh, I'm sorry. Can you repeat that?
Yeah. For git remote -v, I'm trying to understand why there would be two origin, that one is fetch and the other is push, why there would be two separate ones. I don't know if anyone else is seeing that.
Yeah, let me actually take a look at that too. Let me see what mine says I have. That is interesting.
Like the only thing I could think of is there'd be instances where you'd want to have I guess a repository that you'd fetch from in a separate one that you would push to, but I don't see how that could be like practical, or maybe it is used out in the wild that I haven't heard of.
Oh. It is the same, yeah. So is this what you're seeing? Something similar?
Yeah, that's right.
You know, I'd have to look it up, but I think it is possible for you to fetch from one place and probably push to another. You can add multiple remotes.
Cool, thanks.
Great. How's everyone doing? Have you made progress in exercise 2? Do you want me to start working on it? I feel like I'd run through it fast, but feel free to just yell at me and say slow down when I'm doing it. Right. All right, so now step 13 is navigate to the project folder, and you're going to add a new file. I'm going to call this project description. I'm just going to add a line here that says, this is a new file, author, I have date, I'm going to save this. So what is the state of this Git file now? Nothing, because I haven't tracked it yet. Now I'm tracking it. Still nothing. Now if I were to modify it, I get something. Or not. Git status. Added a new file. I'm going to push this. Actually, before I push this, notice that I committed it, right? But what's on my GitHub? Let me actually go into the learn Git repository that I'm in. So I have nothing in here, correct? What I'm going to do now is I'm going to run a git push. Actually, I wonder why that is. Git fetch, git status. feel like I have added, oh, that's because I added my file to the Codesmith project. So my bad. Let me actually add it in here. There we go. I'm just going to do the same basic commands of git add, git commit, added a new file. So you can see here that one file changed, 3 insertions were made, which is accurate because I just added a new file with 3 lines. Once I do a git push, what's going to happen is my push operation created a new file in my learn git repository. Now I'm going to show you how to mess around with the states, right? So I'm going to open this file again. I'm just going to add today's date, which is 20th, 07, 2021. So you can see that this file has been modified. There's a nice, neater way to look at the status. Just type in -s and see that it is modified in my working tree. If it's in the right-hand column, it's so you can actually kind of like tell that there's a left-hand column and a right-hand column. If it's in the right-hand column, it's the state of the file in my working tree. If it's in the left-hand column, it is what it is in the staging area. So if I were to change this again, just add something. Well, actually, I had to commit the previous. I had to commit the previous one. So let's just say git commit -m, changed file. And I'll just add this again. And then we'll take git status -s. Commit -m, file twice. Gonna remove this. Git add, git commit. All right, so you should see all of these changes right here because I pushed them. Now, let me introduce you to something called git log. I like this. You get to see who did what, which is exciting. It's also like a blame tool if some bad entries were made to code. And you can take a look at the log and see who created bad entries, etc. All right. How's everyone doing in questions?
I had a question.
Sure, yeah.
You know how you just log the commits right now?
Yeah.
Does Git let you revert back changes? Like, let's say, can you go back to a specific commit and revert those changes?
Yes, you can. You mean revert it in your local commit, right? Without pushing.
Yeah.
Okay, you can do it both ways though. You can go on to GitHub and you can revert a commit, or you can do it through command. So if you're doing it locally, like you haven't pushed your changes yet, you can revert the commit. And let me actually open my slides up again.
Okay.
Oh, I thought I had some commands here for that, but you can totally revert a commit, and you can do that on GitHub too, even if you push the commit.
Okay.
Yeah.
Thanks.
Yeah.
Do you know what command you use for that, or what kind of like?
Not off the top of my head,
Okay.
but I will look it up and I will let you know.
Okay.
There's a handy cheat sheet that I can share after this that has like a list of all the commands. But I guess if you wanted to revert like files that you can stage, let's say that you've staged some files, right? That's going into a commit and you didn't want those files to go, you can do that by using the remove, I think it's git remove the file or something like that. I have commands for that here, but not a commit, but that's a good question.
Thank you.
All right. Let's actually go through step, what was I? Oh yeah, I was in git log. So that is step 16. In step 17, what I'm gonna do is we're gonna play out the merge conflict scenario where you are your friend and you're going to go on to GitHub and you're gonna add a line here to say, this is from server, okay? And you're gonna commit the changes. So I just played out a scenario where the server changed, but locally what's happening is when I open my local project description, I don't have that line from the server, right? Because I didn't get pull, I didn't get fetch, I didn't do any of that. So I'm not in sync with what's going on the server. What I'm gonna do next is I'm actually gonna run a git fetch. So I'm gonna get the history and I'm gonna get the different versions. When I run a git status now, it's telling me that my branch is behind origin master by 1 commit, which makes sense because someone just added a new commit to my GitHub on that file, right? Now what I'm gonna do is I'm just gonna add my own line here saying this is from local. And I'm gonna run git pull. I'm gonna commit my changes before I run git pull so I can replicate the merge conflict scenario. Please commit your changes or stash them. Git commit -m. I feel like I'm missing a step here. I don't know if anyone is ahead of me in the steps. I added a new line locally. There we go. So I successfully committed that. Now if I were to git pull, gets confused and I have a conflict. So let's open this file again and see what's going on. So you see these lines? This tells me that there's a merge conflict, right? Now I see my friend's line, which is, this is from server, this is from local. I don't like this collaborator friend of mine, so I'm gonna remove all of that and I'm gonna keep my changes. You can resolve, usually merge conflicts are resolved where you have meetings with the team and you all just work on the same file, look at it, at least that's how I've done it in the past. When I've had merge conflicts, some of us are editing the same function, same lines, etc. So once you resolve that merge conflict, all you have to do is commit. Again, I'm just gonna say merged conflict. Oh, it's not possible because I have unmerged. Sorry, what am I doing? So I did this, I have that, git commit -a -m. I've merged the, there we go. So what I did here is I keep forgetting to add things in the staging area. I bypassed that. Instead of doing git add, I just did git commit -a -m. So you're bypassing staging and you're pushing. Just wanted to throw that out there. That's a possibility. That's something you can do too. As you can see, this changed now. I merged the conflict and my line is on GitHub and project description.txt. Once we've done that, we're ready for branching, but I know I cruised through this section, so any questions so far? I see a raised hand. Volkeroy.
Yes. So after you changed the remote one, how did you were you able to sync it or did you delete it? I kind of missed that part. So
Okay, of course, I can
Yeah.
show that again. So this was after I changed this line, right?
yeah.
Okay, well, let's just assume I'm doing it again, right? This is from server
Mhm.
and I commit the changes, right? So someone has edited the file on the remote. Let's just say that I'm always good at this. I always try to be in sync with the server. So every morning when I log in, I git fetch. When I git fetch, what happens is I'm getting all the changes that are there in the server, or all the data and the versions and all the data that's in the server, right? When I open project description, this is what I had locally. This is what I have locally. This is what is there in the server.
Yes.
I didn't. So that's the difference between git fetch and git pull. If I had done a git pull, what it would have done is it would have tried to put this line in my local file. It didn't do that. I just did a git fetch. Okay.
So what
Now,
changed when you did git fetch?
nothing changed. The only thing is that I have everything that's in remote in my local database. So now when I run git status, it knows that there's an extra commit. It knows that I'm behind because there's a new commit that was made to that file. If I hadn't done the git fetch, Git wouldn't have known that.
Oh, so git fetch is done before pull, right? Before syncing the two together?
Not necessarily. I mean, usually yes, but like you can do a git pull directly. What that does is it does a fetch and it does a merge.
Okay.
Okay, does that make sense?
Yeah, so after fetch, did you have to do anything else to sync the remote one with the local one? Or
Yes. So after I did git fetch, I wanted to replicate the scenario of a merge conflict, which is why I edited the file in my exercise and then I did a git pull. I think the same thing would happen right now if I did a git pull. I think it actually merged. We'll see what happened.
okay.
Just overwrote mine.
Okay, thank you.
All right. Any other questions? All right, can we move on to branches then? I'll take that as a yes. All right. I tried to have a joke in here. Case of an emergency, you git commit, you git push, and you get out of building. With that, let's go into branching. Branches in a nutshell. So with other version control systems, you have your main line of development. You can have other environments. Like, I don't know if you guys have worked in projects where you have the testing environment, you have staging environment. Those all have a copy of the code that's in your main line. That can be really tedious to create. So what really sets Git apart is the concept of branches, where you can seamlessly change branches. So you can switch between the main branch, you can go in a different branch, you can have a testing branch. This is let me think of an example that fits. So think of you as starting a company or starting an app, you're building an MVP, you've launched your MVP is in your main line, and your users have come with some feedback saying, hey, we like this new feature. At that point, you want to continue developing on that app. You can create a new branch for that. You can create a new feature branch for that without affecting what is in your main branch. Does that make sense? So switching between branches is really fast, efficient, and it is because Git uses the concept of pointers here for branches, and we'll cover that in a bit. So how Git stores a commit, we'll have to understand this first to understand a little bit of branching. So commit is basically just an object. I know we spoke about this in the previous slides, but it'll make a lot more sense now. So a commit is an object that basically points to a tree object that has a list of all the addresses to files that we have, right? So as you can see here, we have the README file, the address is FB1D3, and etc. and so on. So if I were to change the README file, what's going to happen? Let's play that scenario out. If I were to change the README file, that's going to point to that new file is going to be in a new location. Let's say FB1D4, that's going to be in a new tree object, FB1D4 with that location, and that's going to be a new commit because I would have made changes to that file and committed that file. Make sense? So as you can see, snapshot A is part of one commit. And once we make changes to, let's say, one of the files in snapshot A, we have a new commit that points to the previous commit, and so on and so forth. So we have a chain of commits here. All right, so all along, we have been working on one branch, right? The master branch or the main branch. And our head is basically what branch we are on. That's where it points to. It points to the latest branch or the branch that we're on and the latest commit of that branch. So right now we've been working on the master or main branch and we're pointing to F30AB. If I were to go to create a new branch, what would happen is I'd be creating a new branch. It would be pointing to the same commit because I'm creating a branch off of master, which is fine. My head still points to master, and that's okay because my head's supposed to point only to master until I check out the testing branch. What's going to happen in the next step is I'm going to check out that branch. When I check out a branch, that means I'm telling Git, hey, you know what? I'm going to work on a new line of development or a new, I'm just going to start something new. So that's what's happening here. I say Git checkout testing. Right now I'm pointing to testing, which is off of master right now because we just created the branch. All good. I go on to my next slide. Let's just assume that in my testing branch, I made some changes, and this will all make sense after the third exercise, I promise. So right now, let's just assume that in my testing branch, I maybe added some test files, etc. And I create a commit. What's going to happen is, as you can see, it creates a new commit. And there's this line of separation between this and the master branch, right? I haven't affected master. Master still points to the old commit. Everything's fine there. I just went forward in a different branch, doing something else. Does the concept of branching make sense? Great. Now let's just assume that as I was testing my product, let's take the scenario of I have my MVP app, clients are using that app. Let's just say that the clients had an issue with the app and I have to urgently make a fix. What I can do is I can check out the master branch, and what happens to my head? My head now points to the master branch. That's where I'm working. Head is always going to point to what I'm working on currently, right? So it points to the master branch. I pick the snapshot of files and I make changes to it. I fix the issue that clients have. I check that back in, and I can go back to working on my testing branch. And that is exactly what we are going to cover in exercise 3. Any questions so far? Is anyone actually doing the exercises, or is everyone just sitting back watching me do it? All right, I'm gonna start from step 23. So if you guys are following through or doing it, that's probably a good place to start. I'm gonna start by creating a new branch called testing. Okay, so you can see that I have now switched to a new branch. What I'm going to do next is I'm just going to add a new file to this, right? And I'm going to call it unit test. Once I do that, I'm just going to open it and just add a line. This is a unit test or something like that. Keep in mind, real world wouldn't be notepad files. It would probably be code. All right, now I'm going to say git add, git commit, -m, added a unit test. All right, now let's just assume that in my main line of development, client users had an issue with well, clients had an issue and I need to fix that, right? So what I'm going to do is I'm going to git check out master. So you saw the file disappearing, right? The unit test disappeared. Right now I'm pointing back to the snapshot that I had in my master branch. And I'm just going to say something along the lines of this is a hotfix. I made my fix. Made fixes. I'm going to push that. You can see here, I have my hot fix. Do I have my new branch? No, because I didn't push my new branch. So we'll do that in a bit. I will have to check out my testing branch again. Once I do that, I'm in my testing branch now. Now I will do the same. I think I already committed, but I'll just commit just in case. Unit test added. All right, so I already have it, and also git push, set stream, origin, testing. So remember, anything that's a push and pull operation, at that point, I am interacting with the server, in this case, GitHub. So now you will see I have my testing branch. And if you actually go into Learn Git, you'll see I have my unit test file and my project description file. Any questions so far? All right, now let's talk about merging these two. At some point when I feel like, hey, my testing has all of the information that, oh, I think there's a question. Holka Roy, do you have a question?
Yeah, I wasn't, so my, so I created a new branch, right? And it was supposed to add the file to my repository, right? Mm-hmm. It didn't work for me. Oh, I think I missed a step. Okay, never mind.
Oh,
sorry.
Okay. Do you want to, did you want to like talk about what you think you did or?
Yeah, so for the unit test, I think I forgot to put the txt when I created the file through terminal. Like I just left it at unit test because I saw it as a text, as a quotations, but I was supposed to add the text extension, so I forgot that. I think that was it.
No worries. Why don't we can always like touch base after this workshop and we can probably just like run through those steps again. So you know, you understand branching. Yeah.
Thank you.
All right. So we're back. So just to reiterate, I'm in the last step of this exercise, which is step 28. And so right now I'm going to merge these two branches. Basically, I'm saying testing is ready. It's all done. I'm ready for all the unit test file to go in a master, right? One way to do it is to say git check out master. And I'm just going to merge it with testing. So now let's look at what my master has. Any guesses on what it should have? I think I gave the answer like a minute ago. It should have testing, but it doesn't. Let's just double check this. So my testing has my unit test. My master does not. That is because I merged it, but did I push it? That was what it was. Always remember that. Push and pull operations are necessary. There we go. That merged it. And that I needed to push it to GitHub for it to work.
All right. Question.
Yeah.
I'm sorry. How do you raise a hand? Because I keep interrupting you. And
no. Please interrupt. It's okay.
Trying to check how you raise a hand.
Go ahead. Yeah.
Okay, so when you did, can you pull up the console, please? When you did the I think the push on the branch on you did some kind of like set upstream option, set upstream something in the branch origin testing, right?
Yeah.
Why do you have to do that if you already have checked out the branch? Is that like, aren't you already in the branch testing, and like, do you have to do that all the time, the setup stream?
No, you don't. So that's a great question. If your branch is already on GitHub, you don't have to do that. But I created the branch through command line locally. I did
Oh,
not
okay.
create it on GitHub. That is why I need to say git push setup stream origin. Like, this is a branch on this remote server. That's why you add the set upstream origin in the name of the branch. But if
And
you
that
had created it on GitHub, you wouldn't have to do that.
oh, okay. So that pretty much creates the branch on GitHub on the server
Yeah.
side. Okay. Okay. Thank you.
Yeah. Any other questions? Great questions. Please keep them coming. All right, we're about time, so I might have to cruise through the last section, so I apologize for that, but let's do this. All right, use cases for branching real quick, and then we can end branching. Same thing, right? Separate line of development. Different teams have different branch policies. So sometimes when you're introducing a new feature, you can create a feature-based branch or a topic-based branch. If it's a hot fix or a bug fix, you can have a separate branch for that. Or you can have it based on varying levels of stability. You can have a branch for testing, your staging environment, development, etc. Okay. So this is use cases for branching. Trying to see if I missed something. Yeah, again, going back to the startup example that we went to, right? If you have an MVP app, that can be on your main line of branch. If you have new enhancements, that can be on separate branches, etc. And we just did an exercise on that. Right. Again, sorry for the jokes. May the source be with you, but you have to fetch and pull for that. So please, please do that. I always forget to do that, and then don't like it. So, all right, we're on GitHub now. So someone here, wonderful audience, gave a great introduction to GitHub. So I'm going to conveniently skip that, but I will say it's a server that hosts repositories, much like GitLab or other services if you've all been using that. Give me 1 second. So it is the largest hosting service currently. And what is an open source project? For those of you who want to know, it's basically a kind of license where it's free to use, read, change, distribute. Everyone can see the code basically. So if you're starting out as a software engineer, it's kind of really cool to go on a GitHub and just stalk projects and explore them and see how people code there, right? I've done that. I've enjoyed doing that. Some of the famous open source projects are MongoDB, Android, Python, WordPress, if you've used WordPress. What can you do on GitHub? So you can fork other projects that are cool, fun, and appealing to you. I know I've done that. If you don't have, obviously, you probably won't have access to like some of the projects or most of the projects unless someone grants that to you. So when you don't, what you can do is you can still fork the project. You can find things to do. If you find bugs to fix, you can fix that, submit a pull request. If you're lucky, it's accepted, and just keep expanding your GitHub profile that way. Or you can just be way cooler and create your own repositories and your own open source projects and have other people contribute to that, right? It's all about having fun with it. So it's a nice platform. Explore it when you get the chance. I know I want to and still haven't as much as I should be. So, this, I like GitHub pages. Why I like GitHub pages is you can flaunt all your cool work. Just thought I'd introduce a slide for this one. If you're working on hackathons, if you have a proof of concept, you want to demo it somewhere, you can just, use GitHub pages for that. You can add a link to your LinkedIn, show off every cool thing you've been doing on GitHub using GitHub pages, right? last but not the least, we have a very, very quick exercise on just setting up GitHub pages based on the Learn Git project that we've been working on. So let me go to settings. I'm just going to go to pages. And here I am going to point this to a branch. So in this case, my main branch, which is master. And I'm just going to choose a theme. This is just for funsies. I like having fun. Just adding some glamour to projects we've been working on. Select a theme. You can edit the markdown if you wanted to add an introduction to your project, or if you're creating a React app or something. I think I have a repository right here with like a Pomodoro app, and so I was able to deploy that app onto GitHub pages. So you can do something like that, commit your changes, and voila, now your beautiful repository has a link that goes with it. Let me actually go back to Learn Git. And there you go. You can add more content here specific to your project. But any questions? You want to revisit slides? Do this again?
Would you mind reviewing, like, how would you submit a pull request, and then what would that look like from the maintainer to accept that pull request?
I would love to, but I'm going to struggle because I've done pull requests on Azure DevOps, unfortunately, not much on GitHub. But we can all work together, and if someone has an answer that'll help me, let's actually give it a shot, right? Cool. So let me go to Explore. Let me pretend like I made a beautiful fix for Python versioner. The first step is I would have to clone this project, right? So let's do that. Fork this. Or fork the project. My bad, I said clone. So once I do that, assuming that I made some changes to this, let's see. Oh yeah, there we go. I see pull requests. Create a new pull request. Maybe I have a different branch, right? I have a branch called super new fix or super cool fix or something. So I'll point the branch that I have from my repository, or sorry, from mine. This is Reshma Sekar. So that's mine. So that would be my branch that I have. And then probably I'm super confident, I want to submit it to their master. So I'm going to check their master and submit something. Obviously, if I have something to compare, I think I'll have a button that says submit, and I can probably fill in information and details such as what I'm pull requesting into.
Cool, thank you.
I have a question.
Yeah.
I mean, I think this is just more like a confirmation. It's about the fetch.
Sure, yeah.
So basically, yeah, so one reason that you would do a fetch is just to like compare your local status to the server. Is that what it is? Or because it doesn't merge, right? So
it doesn't merge, yeah. So wait, one of it is, yeah, comparing local status to the server. Maybe you want new branches. I think I've done fetches to get new branches too.
oh yeah.
So like my friend created a new branch and I wanted to just see what they've done and or maybe check that out, make changes to that or something like that.
Okay. Yeah, that was it.
It's something Git fetch or Git pull, some sort of pull operation needs to happen constantly, because especially in projects that are, very fast paced, if you don't do that and you're constantly behind, it can get hard to maintain and manage things, run into issues, merge conflicts and stuff. So any other questions?
Yeah, can you go over again what the purpose of forking a project is and like how's that different from branching? Or is it
Yeah. So here, when you fork a project, usually it's a project that somebody else, has already built, or it's an active ongoing project that you don't have right access to. You're probably not one of the contributors to that project, but you still want to like contribute to that project. At that point, what you can do is you can fork. When you fork it, what happens is you have a local version, or in your repository, you have a version of the project, like Python versioner. When you fork it, you can see I have a version of Python versioner right here. I have a couple actually, like I have pandas, right? This is So I have a version of it. Let's just assume that I found a bug for pandas and I wanted to fix that bug. What I can do is I can first fix that bug locally in my repository. Once I'm done fixing that bug in my repository, I can submit a pull request to the original pandas, whoever the owner is. And if that is accepted, then I fix the bug for them. So take my word with a grain of salt. I've never been able to contribute to an open source project myself. Hopefully one day that will change. But from what I've read, I'm pretty sure that's how it happens. The only pull requests I've done are for like projects at work. But I hope that answers your question.
Yeah, it does. Thank you. I always wonder what a pull request was.
I have one question for you.
Yeah.
So I know that some people, they'll have their backend and their front end code in separate repositories, and then they'll merge those two repositories. How would you go about merging two repositories together?
I do not know the answer to that, Chadwick, but that is a question that I hope I will eventually know the answer to. Merging two repositories. I'll have to look that up.
Yeah, because I was just wondering, because I have no idea. But...
I mean, the thing. So you have backend in one repository, front end in another. Yeah, I guess like backend would be an own app, front end would be its own app, and then you kind of connect the two, right? Because your front end is always going to call like maybe an API or something that the backend is. So I don't know if you necessarily need to merge the repositories if it's two independent. I guess it depends on the.
Actually, yeah. Yeah, it was explained to me a while back, but I feel like you might not, probably don't need to merge those two repositories. That would make sense.
Yeah, I mean, especially if they're independent apps running and one's just calling the other. Yeah. I see more raised hands. Jay, did you want to ask your questions?
Sure. This is just kind of more of a general question, but like, does it happen then if a bunch of people are working on a project that like someone overwrites something that someone else is doing, or like the merges and syncs don't line up, so like things get lost and stuff like that? Because anytime I see branches and merges, that's always kind of like, I know it's necessary to make the project work and for people to work on it, but it seems like there can be some issues, right?
Yeah. So one of the biggest advantages with Git is you can't lose data, right? So overwriting, yes, it may happen. What happens is maybe there was a merge conflict and I pulled my coworker's changes and I just scrapped all his changes and put mine in and just submitted that. But that being said, when it's caught, what happens is his data is still there in a different version. And then we all sit together as a team and discuss how we, how we deal with that conflict and how we go forward. That makes sense. So you can't lose data at all if that's what you're asking. I know it's a little complicated. That's why you ask questions with your you sit and walk through things like what is your branch policy with your team, how you branch out, what things you work on. I think with good project management, something like that, can work or will work. Git's actually very useful for that.
Cool, thank you.
Does that answer your question?
Yes, thank you.
All right, any more questions? No? Did everyone learn anything? Did you get it? If you get it, that's all I need to know.
Folks who know
Sorry,
me
go ahead.
know I love puns, so I love the joke. Well, thank you so much for giving us this introduction to Git and walking us through all of these exercises. We do have a lot more free workshops and events on a weekly basis, almost every single day of the week. So definitely check that out. I pasted the link in the chat. And then also feel free to join our CSX Slack community if you haven't already, to connect with other folks and mentors. If you're currently working on projects and need help on those, there's a bunch of people on there who are always happy to jump in and help out. But thank you all so much for tuning in, and thanks, Reshma, again.